What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video I'm going to talk about absolute and local extrema, which are extreme values. And so we have absolute and local maxima, which is the plural of maximum, as well as absolute and local minima, which is the plural of minimum. And sometimes instead of absolute you'll see the word global, means the same thing. And sometimes instead of local you'll see the word relative, means the same thing. Those are synonyms. So we're going to practice identifying these features by looking at a couple of different graphs. So let's start. What is a local maximum of a function? It's an output or a y value that is greater than all the nearby y values. So graphically this looks like a peak, a hill, a mountain, a point, right? Here we see a y value and it's greater than all of the nearby y values. So the function has a local max here and another one here. This function has two local maxima. So how can we describe these? Let's say this function is f. So there's a couple different ways we can describe this local maximum here. We could say the function f has a local max when x equals -3. And I want to write this out because I want to show why I don't like this. Here's why. We're stating the location of the local max, but we're not stating what the max value is. We're just telling you where it is. So if I'm asked to identify the local max, I've only identified where it is, not what it is, so I don't like this. We're missing a really important piece of information here. So let's erase this and make it better. What could we say? We could say f has a local max of, and we could say what the local max is, 4. Boom. So I like this a lot better. We're saying what the local max value is, but now we're missing the location, which is information we have. And that seems important. Like, why not tell someone the location of it if we know it? So here's how we can add on to this and make it even better, is that the function has a local max of 4 when x equals -3. So we're stating the max value and we're giving the location. And another way we could say this is that f has a local max at, and we could write it as a point. And we could say -3, 4, and this is providing all of the information we have, the location of the max and what the actual max is. So key idea here is check with your instructor, check with their expectations, make sure you read the task, figure out how they want you to write it. In this video I'm going to write it in one of these two ways, either by giving the max value and stating where it is, or by describing it as a point. Okay, so this function has two local maxima, one here and one here. Now, what is an absolute maximum? It's an output or y value that is greater than all other outputs of the function. So local is just greater than the nearby y values. Absolute is greater than all of the other y values. So there's only one, and that's here. This function has an absolute max of 4 when x equals -3, or absolute max at the point -3, 4. So what you'll notice is, wait a minute, this is an absolute max, but back here we said it was also a local max. And that's always the case. Every absolute max is also a local max, because if it's bigger than all of the other y values of the function, then it has to be bigger than all of the nearby y values of the function. But not every local max is an absolute max. This is a local max, but it's not absolute. It's not bigger than all of the other y values. So key idea there, if you're confused about how come every time I find an absolute max, I'm also saying it's a local max? Yep, that's a thing. Every absolute max is also a local max. So now we can repeat these same concepts for minimum. All you're doing is replacing the word maximum with minimum, and then replacing the phrase greater than with less than. So a local minimum is less than all the nearby y values, and absolute minimum is less than all of the other y values, and every absolute minimum is a local minimum. So we're going to go through two examples. This is the function we already saw. We're going to describe local max, local min, absolute max, absolute min, and then we're going to do it for one more example at the end. So let's start. We identified two local maxima earlier. We said one was here and one was here. So we could say local max of 4 when x equals -3, or we could say there's a local max of 2 when x equals 2. And we could also describe, I'll draw a line here, we could also describe these as points. We could say there's a local max at -3, 4. So again, we're checking with our instructor and seeing how they want us to write this. We could also say there's a local max at the 0.22. All right, we also already identified the absolute max. We said one of these y values is bigger than all of the other y values, and that's this one here, 4. So we could say there's an absolute max of 4 when x equals negative 3, which we could again describe as a point, negative 3, 4. And we could say that's where the local max is at. Now let's move on to minimum values. We haven't really looked at those yet. So we're looking at peaks, but the opposite direction, like this. And I see one here. I see a smallest y value. It's smaller than all the nearby y values here. So it's a peak again, but that opposite direction, like a smiley face. Okay. So what is the actual minimum value? It's negative 2. That's a local minimum, negative 2. And that's when x equals 0. And we can describe that as a point. We could say it's at the point 0, negative 2. What about an absolute minimum? What y value on this graph is smaller than all of the other y values? This is a little bit tricky, but there is none. There is no absolute minimum because the function goes down forever and ever. That's what these arrows mean. It decreases forever and ever. There is no smallest y value. No matter what y value we pick, the function will cross below it and get smaller. It goes down to negative infinity. So that's the concept of infinity, right? Going on forever and ever. So there's no absolute minimum on this graph. All right, let's do one more example. And here's when I encourage you, pause the video, pull out a pencil and paper, try this on your own. This is your check for understanding. Use the video to check your work. All right, I see one local max, and that's here. And that's when x equals 1, the local max is 2. So we're going to say the local max is 2, and that happens when x equals 1. And then we could also describe it as a point. We could say the local max is at this point, 1, 2. All right, let's see. What about minimum values? I see 2 of those. So again, we're looking for these smiley face peaks in the opposite direction. So I see one here and one here. So we have a minimum value of negative 1. So local minimum, negative 1 when x equals negative 1. And then we also have a local minimum down here at negative 3. So negative 3, and that happens when x equals 2. So again, we're describing the minimum values and their location. Awesome. Now let's look at absolute. Is there an absolute maximum value? Well, I had this local max, so I can check that. Is that the biggest of all the y values? No, it's not. Is there a biggest y value? No, there's not. It goes up forever and ever. So it's like the opposite of the last one, which went down forever and ever. This one increases forever and ever. The y values get as big as possible all the way toward infinity. There is no absolute max. None. What about an absolute minimum? Well, let's see. I described 2 local minima, and that's typically our strategy. If we're going from local to absolute, we go back and look at our locals, and we see which of those is either the smallest or the biggest, depending on whether we're looking at minimum or maximum values, right? So minimum values, I see 2 of them. This one's the smallest. Is it smaller than all of the other y values? Yes, negative 3 is. So we can say the absolute minimum is negative 3, and that occurs when x equals 2. So we have a minimum value of negative 3, and that's another way we could say this. F has a minimum value of negative 3. So minimum value, if we're just saying that in general, it typically means absolute or global, the smallest of all, or maximum value, biggest of all, right? So again, we could also describe this as a point and say the function has an absolute minimum at this point. Hopefully this video helped. Like the video, subscribe, do all that stuff to support me. Leave any questions in the comments below, but most importantly, keep flexing those brain muscles, and I'll see y'all later.